Today we are doing lesson 6.1, and since it is the beginning of the chapter, I'll go over the outline of the book. That this chapter is on quadrilaterals, so we're starting with some basic properties of polygons, moving on specifically to four-sided figures, quadrilaterals, right, being parallelograms, so different properties of parallelograms and vice versa. How do we know a four-sided figure is a parallelogram? So a lot of overlap in the first in lesson 2.3. Then we'll go over specific parallelograms such as rhombuses, rectangles, squares, some non-parallelograms like trapezoids and kites, and some other special quadrilaterals. So just a note in this chapter, we will have a goal to get through 6.6 before semester 1 final, but we won't get to a test, so we will quiz on the material, but we will not test on chapter 6. 6.1 is the goal to identify and classify polygons and find angle measures in quadrilaterals. So starting off here, a polygon means many sides, I believe in Greek, poly, and it is a shape with 3 or more straight sides. So we're talking non-curved, so circles, semicircles, hearts, those are not considered polygons. The endpoint where 2 sides meet is called a vertex, right? So in this picture of a pentagon here, we've got 5 vertex is, which is the plural of vertexes, vertices. So we have 5 vertices, and we've got also, conveniently, 5 sides in that diagram. Diagonals of a polygon are segments that connect 2 non-consecutive vertices. Now, A is consecutive to E and B. So if we draw diagonals to the other non-E and B side, we end up with 2 diagonals there, right? So in this picture, each vertex has 2 diagonals. Is a figure a polygon? So what you're looking at here are all our sides connected, are all of them straight? And that's the main thing here. So this one, I've got all 4 straight sides. Yes, that is a polygon. Over here, I've got a circle, not a polygon, right? Rounded side, meaning straight side. Over here, looks a little funny, but all these sides are straight, so that is, yes, a polygon. Over here, we don't really connect at the end, so this would not be considered a polygon. Right, so you need to connect at the end. We need to be an enclosed shape. Next, there are 6 different types of polygons. We've got triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, and pardon me, there's more than 6, but these are the number that we have for, again, a 3-sided, any 3-sided would be called a triangle, any 4-sided would be called a quadrilateral, and again, based on the number of sides, we've got a name. Pentagon would be 5 sides, hexagon would be 6, hex for 6, 7 would be a heptagon, octagon 8. They actually continue. Nonagon is for 9, decagon for 10. But these are mostly the ones we're going to focus on today, the ones above, 9-sided, 10-sided. Some might ask, well, what about 11? What about 12? Most all polygons, 10, 12, 13, 15 sides, whatever, have a name. However, generally, once it gets beyond 10, we commonly use the phrase n-gon, meaning, say I have like 15 sides, we would call that a 15-gon. If you Google it, I'm sure you could find the exact name, what it's called, but generally speaking, once we're over 10, we usually call them 11-sided, so that'd be 11-gon, right? Determine whether it's a polygon or not, and if it is, tell which type it is. So here, 1, 2, 3, 4 sides are all straight, and again, I'm counting while I go around and classifying. So yes, it's a polygon, and now I need to classify, right? And again, this is if yes, one more step, and that is 4-sided, therefore it's a quadrilateral. Do your best with spelling. Generally, you have your notes available to you. Now this one, it kind of looks like a pill. We've got curved side, which means not a polygon, and that's all we need to do. If it's no, we're not going to give it a label. Next, we have this kind of hourglass looking figure that doesn't work, right? We can't have our sides overlapping, twisting like that. So that one is not a polygon. Then over here, again, you just pick a side to start with and say that's 1. And then counting as I go around, I've got 6 sides. They're all flat. They're all connected. That's going to be a 6-sided figure, which is a hexagon. So again, yes, a polygon, more specifically, a hexagon. A couple more rules, okay? A rule is, in this case, triangles add to 180, so what would a quadrilateral add up to? Again, every quadrilateral, if I draw a diagonal, now we have 2 triangles, therefore 2 groups of 180 is 360 degrees. So all 4 angles of a quadrilateral inside, notice inside angles, add to 360. With that information, we can have diagrams that have 3 angles, and we can solve for the missing angles. So solving for angle A, this looks like a kind of upside down trapezoid possibly. We've got 72, 108, 108, and then A. So we would just make the equation 72 plus 108 plus 108 plus we don't know, so angle A is 360, and our solve, again, notice the steps going into a solve specifically are to find one angle here. I'm going to take 360 and subtract the other 3 angles. So minus 72, minus 108, minus 108, especially if you're using a calculator here. So we subtracted 108 twice and 72. And then totaling these up, I've got 180, 280, 288, taking that away from 360, and I get 72 degrees is angle A. But again, you use a calculator there and just subtract, take 360 minus the other 3 angles. Next one, we got the same situation with 70, 80, 70, and angle S. So angle S plus 70 plus 80 plus 70 equals 360, and we're subtracting all the other angles from that. So minus 70, minus 80, minus 70 on both sides. So totaling up in my head, I got minus 220 there, and that leaves me with 140 degrees is measure of angle S. And that wraps up today's lesson. Feel free to do the homework assigned on 6-1.